Alright, hello. We're going to go through just a quick lab setup. If you're just beginning your Cisco studies, this is just a quick down and dirty on getting something up and running so you don't get bored. So here I have Eve installed. It's just a virtualization environment. Anyways, I'm going to add a node and I'm going to add just a couple of routers here. Let me just add 4 for now, but it doesn't matter. And I'm going to change this to I don't know, what can we call this? How about just router? That'll work, right? And then that'll work. Okay. So I have my 2 routers here. This one and this one. And I'm just going to connect them to gig 0. Easy enough. Okay, now we're going to get into the fun of it. So I'm going to start it. And I'm going to start this one. And then here I have secure CRT running. So we'll be able to see that one. And I'm going to open up the other one. There we go. Now I got 13 and 14 running. I can close these. I don't need them. Gone. Okay. So while they're starting, I am going to set up the network here visually. Go back to the Eve topology. We'll just put those ones aside for now. Okay, so this is the network we're going to create. Just going to make it something that everyone's familiar with. Just be 1.0/24. That'll be my network. Okay. And then this is, I should have renamed that, but whatever. This is going to be router 1, and it's going to be on the same network, and it's going to be .1. That's its IP address. And I should have. Okay, whatever. It doesn't like me. Delete. Okay, whatever. We'll get rid of that. We'll try again. Yeah, router 1. That's going to be the host name. And that font size is going to be 16. There we go. Oops, I forgot to do this too. Get rid of that. I'll do it again. Oh, that's why it does it down there. Huh, I didn't even know that. Okay. Well, that's fine, but it's not giving me a... Yeah. Okay, good. So that's router 1. And then down here is going to be router 2. Oops, I almost forgot. That'll be .2. Alright. So that's going to be the network setup. Just pretty easy. And let's go back to secure CRT. And okay, we got our dialog box. Skip this stuff. You can go through it once if you like. I don't recommend it. But anyways, that's doing more of its stuff in the background. I'll just go no here. Okay, good. Now I'm gonna go into enable mode because I'm at my router prompt, which is my user exec level. Oh, hang on a second. It's still doing stuff. This is because of virtualization. Okay, there we go. I don't know what it's doing. Whatever. So this symbol right here, that means I'm in user exec mode. I have very limited commands I can type, but we'll dig into those later. So let's, there we go. Okay, clean screen. Now I'm going to go into my enable mode, and you'll see my prompt changes. All right, then we're going to go into, this is called either enable mode or privilege mode or privilege exec mode. Now we're going to go into global configuration mode, which is configure and then terminal. And you see how it says Control Z? I can go back. That's pretty easy. Now you can do a shortcut and just go Conf T, because Cisco will try to auto-populate the rest of the word as long as it's not ambiguous. In other words, if it's unique. If it's unique, it'll do it. If there's more than one, for example, if I try to do this, it's just going to tell me ambiguous command. What does that mean? Well, we can go C question mark, and then you can see there's a lot more than just one C, whatever. Anyways, the shortest we can go is not that. It is Conf T. Okay, now we're going to start configuring. First thing I want to do, give it a host name. Actually, even before then, just as a little tip, a lot of people do this. You'll want to go no IP domain lookup. There. And I will show you what happens when you don't type that on the next router. I'll show you why. But now we're gonna get right to the configuration. We're gonna do, well, one other thing I want to do too is line console 0. So you can see now how it annoyingly just kind of puts these messages up that I have to enter to get another prompt. Well, I can fix that. I can just go logging synchronous. Boom. Now when it pops up another line, here, I'll show you. It'll automatically go to the next prompt without me hitting enter. All right, well, let's go back into this. So first thing I'm going to do is give it a host name. It's going to be router 1. Boom, host name. That's easy, right? Now I'm going to go into, what is it, gig 00. So I'm going to do interface, gigabit Ethernet, and then my options are 0 through 4, but I know it's on 0/0. Now I'm going to give it an IP address. Oh, IP address, and then 192.160. Well, I typed that twice. 1.1, and now it wants a subnet mask. It has to know which network to talk on. I mean, we're giving it a unique identity with this IP address, but we have to tell it what network it talks on. So it's going to talk on this network. That's just a simple Class C network. And we'll hit enter. And I want to do no shutdown. So I enable the interface. And now we'll see a couple of messages appear saying it's up, down, and up. And then we'll see it'll go down here in a second. Right now the link went from down to up. And it's telling me that right now. And that's the physical. And then you see the second one there. That's the protocol. That's the logical. And that went from down to up. And in a little bit, I don't know, I don't want to wait around that long, but you'll see it'll go back down logically because the other side is shut down right now. So let's go to the other side. Go to this router. There. Okay. So a shortcut for enable is en, and then conft, and I already showed you the logging synchronous, so I'm just gonna go to this, and it's like one of the first things I do. Okay, so one thing that'll happen is this right here. We're gonna do, that's not even a command. All right, so you see how I tried to translate it? That's because IP domain lookup is on. In a real router, what'll happen is it'll just keep cycling for 30 hops. And those 30 hops are, I don't know, anywhere from 30 seconds or so a piece. So, you know, you're going to wait a few minutes for it to time out. Or you can kill it. But we'll just nip that right in the head right now and do no IP domain lookup. And now it won't ever do that again. It just doesn't even try. See the difference? It doesn't even try to translate it anymore. An IP domain is DNS lookup. It tries to do a DNS lookup, hence the domain server. But anyways, now we're going to configure the host name. Oops, I totally messed up that command. Host name, I can't spell, router 2. And now we have our host name. Now let's go, well, before we do that, because I already showed you, we went into it quickly. But let's say, for example, we didn't know the interface off the top of our head, because, you know, all those zeros. So let's go back into privilege exec mode, and let's do a show IP interface brief. Now you can see we have our gigabit 00. It doesn't matter if the 00 is space between the gigabit Ethernet or not. It really doesn't matter. When you get into other way more advanced configurations, and some of those aspects it will matter, but you don't have to worry about that. So anyways, so we have the host name. Now we're going to go into the interface, which I just type int G0000, and that gives me into the gigabit Ethernet. Now we'll do IP add, which adds a shortcut for address. You can see there are no more options. So IP add and then my address. And I'll just hit question mark here, and I'll show you. It tells you it wants an IP subnet mask in an A.B.C.D format. In other words, 4 octets. Hence, IP version 4. And then this is going to be our subnet mask. Let's say I messed up. Let's say I did 256. Here's what's going to happen. It's going to say, I don't recognize that. So it's error checking. And of course I can hit the up arrow key and get back. So we're just going to do 0. And I'm not going to get into subnetting. We're just doing quick down and dirty, getting the network working. Okay. Now I'm not going to activate this interface yet, because I want to show you something. So let's do end. You have 2 options here. Okay. So first, if you look here, we're in global configuration mode. However, we're in this sub configuration mode called interface configuration mode. So this is interface, IF for interface, and then configuration. So interface configuration mode. Okay, so that means, think of it like a hierarchy, like a hierarchical tree. I'm 2 up. So if I want to go back down in just regular global configuration mode, I just type exit. Now I'm back in global configuration mode. But hang on a second, let's go back up 1. And if I want to go all the way back to privilege exec mode, I can just type end. And you see I'm back in privilege exec mode. Alternatively, and this is stuff to keep in mind, Cisco's going to ask you about this for exams. You can go exit, and you see I'm back down. I'm down 1, and then exit, and I'm back. I'm down another 1. So exit brings you back 1, end brings you back all the way to the beginning. Okay, so now let's do this other command we did before. Show IP interface brief. I just abbreviated it this time. Now you'll see we have an IP address configured on gigabit. Whoops, I moved the wheel of the mouse. Let me fix that. There we go. So the IP address, and you see it's administratively down because I didn't enable it. And here you see down, down. Now let's go back to this other router for a minute. And end, show IP interface brief. I think this is a hiccup of a virtual environment. I would expect this to be down. But maybe that's because it's virtual. I'll have to turn on the routers later. Well, I don't have to turn on the routers. I know that's what'll happen. But anyways, we can see something else too. I can do show or show IP ARP, and we'll just look at the whole entire ARP table. Make it simple. It only knows 1 IP address. So there's proof that even though it says protocol up, it's not receiving anything. If we go over here to this one and do show I can't spell, show IP ARP, nothing, because the interface is not active, so the interface doesn't know anything. Alright, so let's fix that. I went through this before, so we'll just go into the interface, and then I'll just do no shut for no shutdown. And now we should see it come up. I'm just going to go back to privilege exec mode. And now before we mess around with router 2, we're going to go back to router 1 here. And I'm just going to do show IP ARP again. And it doesn't have it in the table. Why do you think that is? Let's fix that. Let's do ping 192.168.1.2. You know what? Before I do that, let's do this. I know I'm kind of jumping all over, but let me shut the port back down. Okay, so now we know. Now we know the port. Why'd the port up? Why is the port up? Oh, because I typed the wrong command. I'm used to activating them here. There we go. Okay, now it's back down. Okay. Let's try to ping it. Nothing. Absolutely nothing. Let's just ping it one more time. Because sometimes, because of ARP, the way it works in the background, sometimes it takes a couple of iterations. But in this case, it's not going to work. And we can do show IP ARP again. And you see it, because of I turned on that interface for just a split second, it saw something, but I turned it off before I knew what was happening. But I can do, I think the command is clear ARP, and then show IP ARP once again. And now you see the ARP table is gone again. All right. And let's just do this one more time. Just to see if we can see if you see. I just want to show that the ARP table will not populate. That was only because I activated that interface. Okay, we'll do it twice. We'll do the same exact thing I did before. All right. Okay, good. Now we'll do show IP ARP. And it does see something. Okay, so I'm gonna have to redo this using real routers. And I will. I'll make another. Well, I can pause and go turn them on, but let's finish this up first. So we're gonna activate this interface and do no shut. Now we'll go back to here. Okay, after we see it turned up. And let's do show IP ARP. Yeah, see it. It's incomplete. It doesn't know what's happening, so there's nothing there. Well, let's do this. Let's ping it. Probably we'll see a few of them fail, or one, and that's because it has to send out a broadcast message to receive the MAC address and the IP address. And once it receives that, it can add it to the ARP table and add it to the routing table. I'll show you the routing table in a minute. So what happened was, this router 1, sent out a broadcast to, and I'll just type it here, to this IP address. The 1.255 IP address. Why did it send it to that one? Because I defined this to be my subnet mask on my interfaces. And once you get into IP addressing, then you'll start to understand the correlation. Anyways, it sent out that broadcast. That broadcast is just a layer 2 broadcast, and it can only go through switches or something that's directly connected to that interface only. It won't go from, for example, it won't go from gigabit 00 to gigabit 01 to 02 to 03. It won't send a broadcast out those ones, even if I had them configured. And then it would ask, who has this IP address? That's what the message asks. It asks, who has this IP address? And because in this environment, I only have router 2 configured, router 2 says, me, I have this IP address. And I can do this command. I can do show interface, gigabit 00. And here, you can see the MAC address. And this is the same. There's ways to change this, but we're not going to go into that. BIA is burned in address. That's the hard-coded address from the factory. You can change this address, but we won't go into that. But anyways, you can see this is the address. And we go back over here. And we'll look at the hardware table right here. Bam. There's the hardware address. See, it says E. That's the difference. I'll go back over to router 2. And you'll see there's an E right there. Okay, so this guy says, yes, that is my IP address, and here is my MAC address. And it sends the MAC address to router 1. Now, I didn't do anything on router 2 as far as pinging. Let's look at the ARP table. Show IP ARP. And bam. They know each other. Why? Because they communicated. That's why. It's not just a one-way communication. Okay, what else can I talk about while I'm over here? Let's go back to this interface command. And you can see ARP by default is 5 minutes. This one is 4 minutes for some reason. I don't know why. This just must be a virtualization thing. I think that's it. I mean, this is the IP address that I configured on it, /24. That's our Class C address. Let's look at something here. So I sent 76 packets. Let's look at the packets over here. Show interface gig 00. 29 packets input, 175 packets output. That's from those pings that I was doing when the interfaces were down and whatnot. But anyways, what else can I talk about? The routing table. Let's look at the routing table. So I can just do show IP route. And this is the routing table. Ignore all these. We're just going to concentrate on this down here. I'm not going to go through everything in here in excruciating detail. I'm just going to quick down and dirty. This is our network. And under this network, see how it's indented in? It knows that that network is directly connected to that interface. It also knows, see how it says C? Now we'll go up here to the top to our legend. C connected. That's directly connected. Okay. What does that mean? That means that network is connected to that interface. That's all it means. It means no other networks are connected to that interface. Okay. So now we see L for local. Up here in the legend, you can see where that is stated. And this IP address, which is /32 subnet mask, /32 just means it's a host IP address. That's all it means. It means this host IP address is directly connected to this interface. That's all it means. It means this IP address belongs to this interface. That's all it means. Okay, now let's do one other command. We'll do show IP route, and let's see how we get to 1.2. Let's see what the routing table looks like now. So the routing table says this is the network that you're asking about. It's connected via an interface. Okay, that's all it's saying. Now we'll go a little bit into the details. Down here it says it's directly connected. In other words, there are no additional hops. And it's connected via this interface. That's it. That's all it's saying. Yeah, there's some more stuff in here, but I'm not going to go into that. This is just getting a network up and running. And now I'm going to go on router 2. And we're just going to ping the other guy. There you go. Ping. So it's going to show me the same thing. Show IP route. Same thing, except because that interface is configured on that, or that IP address is configured on that interface, it says .2, but again, it knows about that network. And you can do this one. How do we get to that? It's the same thing, since they're point-to-point network. It's that easy. Okay, now I'm going to do a little bonus, and I'm going to turn on some real routers, and we'll look at those. I am going to do, which ones do I want to turn on? We're going to do, yeah, we'll turn on this one. That's not what I wanted to click on. We're going to turn on this one and this one. Okay, so I'm going to pause I'm going to mute it. And while I mute it, I'm going to go turn on my routers, and you're going to look at the router boot sequence. These are 1841s. They're considered an ISR, an integrated service router, which just means they can do more than just basic routing. A service provider, not today, but when they were in, the latest and greatest, service providers would use these at customer edge because they would do routing, and then they could put additional module cards in them to plug all their unique cables into them, because it's not just Ethernet cable. I mean, we're talking T1 lines and other types of cables they would plug into them, or something proprietary to that. So anyways, these are called ISRs. And anyways, you're going to watch it boot up. Okay, we can see the routers. Let me move the cursor out of the way. The router's booting up, and I turned on a third router, and I'm just going to show you a little bit more, and we'll look at a routing table as it populates as we start to add more configuration. I guess this is going to be longer there than I anticipated, but that's okay. So this will take just a few minutes. That's normal. These aren't very large routers as far as capacity goes. They're simple. They're just stripped down, and there's not a whole lot to load. For example, you can compare it to like a 6500 series or an ASR 9K or something like that. You know what? Let me show you a picture of one. I'm going to pull a picture up here, and let's just do, here. And we'll do images. I'll show you this in a minute, but you're just looking at the router boot anyway. It's about done. Yeah, this is really good right here. So I'm going to check to see if this is done. I don't think it is. Yeah. Alright, so when this is done booting, I'll show you the picture of what a 1841 looks like. Okay, here we go. This is the boring part, but what are you going to do? Doesn't take 20 minutes, that's what's important. So one thing to note here, it has 2 fast Ethernet interfaces and 1 serial interface, and then 1 VPN module. This is what I'm talking about with an ISR. Normal routers just have a fast Ethernet interface and a serial interface. But this has the capability for a VPN module. So you don't have to have a separate VPN device in order to do VPN functionality. Hence, a Cisco 5585, for example, or a 5520 or a 5501. Any of the ASA models. Alright. This is just more messages just starting up. But it's done. It's ready. I already have it configured, but I'm just going to erase it and start over. It's pretty simple. So here's what the router looks like. And we'll look at the front. Maybe. Okay, so here's the front. Nothing fancy, right? Yeah, that's normal. And that's not really that good of a view. And I'll show you a better view here in a minute. But this is what the back looks like. And the front is up there with the faceplate on. Here's a better view of the back. Let's move this over a little bit more. There we go. Okay, so this is the CF card or the compact flash. This is the USB port. That's just a lock, like a laptop lock. I'm sure you know what that is. These are the fast Ethernet interfaces. 00 on the bottom, 01 on the top. They're not gigabit, they're just fast Ethernet. They only run at 100 megabits per second, not 1000. The top here, see how it's blue? Blue signifies console. And the bottom is aux, so we won't deal with the aux port. There's nothing to worry about that. These 2 ports, slot 0 on the right, slot 1 on the left. Those are just where you can insert different modules. And I'll show you what one looks like in a minute. Let's see, there's the power switch, ground screw if you want to attach a ground to it, and just a standard computer power cable. That's it. There's really nothing more to these, and they're not that big either. I mean, these things are kind of tiny. They're probably like, I don't know, 12 inches wide by maybe 8 inches deep, and they're what, 1.75 inches tall. I know that's a weird number to say, but that's because they're 1U, and 1U is 1 rack unit. And anyways, I didn't make it up. Okay, so here's a picture of one showing some stuff connected. This is what I have. I have fast Ethernet 00 connected to 00 of the next router. So router 1 and router 2 connect via 00, and router 2 and router 3, which I have a third router, which I'm going to play around with here in a minute, connect via 01. This is one example of an extra interface card you can add to them. It's just a fast Ethernet interface card. I have one, and it came in helpful with my CCNP studies. I needed it. It was $160. Yes, that's a lot of money for something that's really old. But, I wanted to do the labs, using those. Let's see if I can find. Yeah. Here's a picture. So this is called a Ethernet module. So these act like these aren't routed ports. In other words, they're just layer 2, and they share. This acts like a switch. It's like a switch module. Let's go to. I'm not going to go into too much details of these. This is one example of what a serial one looks like. See how it's got. This is really. Let me see if I can find a better picture of that one. So yeah, this is another example there. Here we go. Here's a good close up. So this is Fast Ethernet 0, Fast Ethernet 1. So this is just an example of what these look like. Let me see if I can find one that doesn't have watermarks on it. Might have to search for it. Yeah, here we go. There's different types of serial cables, so keep that in mind. So here you can see this big long trapezoidal thing connection. That's a serial. Let's see here. Here's another one. This is a really good picture of one. This is considered high-speed serial. Just a lot better, a lot faster transfer rates, and it's a smaller footprint. You can put up to 4 of these on one of these little cards. And I was looking for. Okay. So here's another example of a module you can put in those. You see how it says ISR 1800. I have an 1841, so it's in the same series. This is compatible. This is an example of you would put on the customer's edge, so they can plug, their cable directly into it. Just like you have a cable modem in your house, this is the same thing. It's just a module. It's just a card you put in it. That's it. Okay, well anyways, there's another serial interface I want to show real quick. And if I can't find it, yeah, I'm just going to do a search for it. So, Cisco, what is it called? Sync module. Okay, so is this it? I can't hardly. Yeah, that's not it. But that's a horrible picture. I don't know what happened there. That is not it. It's not what I'm looking for. You can see there's a ton of them. So let's try serial module. There we go. Here's what I'm looking for. Whoops. Why are we going? Oh, because it's up there. Here we go. Okay. So real quick, we'll go back to Secure CRT, and I showed you that one serial interface was installed. That is this puppy right here. Notice it's trapezoidal. Yes, orientation matters. And just as a tip, some manufacturers, the cable end might wear out just a little bit, or they may not be manufactured to Cisco's complete specifications, and you can turn them upside down and plug them in. They're not going to work, but they'll plug in because the pin arrangement is just in a straight rectangle. So there's no key to it. The only key is you just have to do due diligence and look. Okay, so enough of this crap. Let's get out of here. Let's get out of that. Let's go back to the router. Let's configure these ones. So the first thing I'm going to do is go into privilege exec mode, and I'm going to do write erase. And that's going to erase it. And then I'm just going to type reload. I guess I could have done this while I was on the web, but whatever. Now it's going to reboot because I typed reload. That's the reboot command. I'm going to do the same thing here, except I believe these routers will allow erase, and then I can do startup config. And that's another option, and I would try to remember that. But here we go. You can see these are my options. I want to erase the configuration memory. So again, startup config. But before I do that, I'm going to do write, and then erase NV memory. So I can erase the startup config, I can erase NV memory, I can erase all of it. So that's just something to study. I just like to use write erase, or just shortcut it, WR erase. But anyways, that erases everything. We're going to start, like I said, with a clean slate, reload it, and that's booting. Okay. This is loading. I'm going to configure the same IP addresses on here. Yeah, we're just waiting for it. La la la. And I do recommend, well, while that's booting, let's look at the 1841s on eBay. So let's go, eBay is where you want to get your routers. So let's do Cisco 1841. Some of these are expensive. I wouldn't pay much over $30 for them. Have I paid significantly more? Yes, but the market was a lot more expensive back then. So let's organize this. I recommend 64 gigabit flash card. It says it doesn't support it. It does. And I will show you that. But that's the one I recommend. And these are the screws that hold your rack ears in place. And I'll show you the rack ears in a minute. I recommend 128 gigs of RAM. Third-party RAM will work just fine. $6, $5, something like that, right around this price. It's a good price for that. So the 128 megabytes of RAM is going to enable you to run 15.1 code, which I'll show you in a minute, but you see I have that loaded on mine. And these are the rack mounts or the rack ears. You see they call them rack mount bracket ears, just a whole bunch of keywords. Anyways, they all come with screws, but you know, sometimes things happen. So anyways, those are it. And we'll scroll down. It looks like yeah, it doesn't have to be a Cisco CF flash, but you can see the 128 ones are like super cheap. Just stick with those and it'll work. You can do funky things with USB, but I wouldn't even try. There's the wick. That's what I paid, $10 a piece for mine. I have like a dozen of them or something, and they're very helpful. Looks like power supply, $10. All right, it's good to have parts. I would not pay $8 for a power cord. Most your devices will come with one. Faceplate you don't need. It's just cosmetic. Some of mine have them, some of them don't. I'd like them to have it, but whatever. All right, so let's pump this up to 200. Let's look at the routers. Scroll down. See, there's all sorts of replacement parts for these things. All right, so here we go. Here's one. This is actually a really good deal, and it's coming from Wisconsin. I can make this bigger. There we go. Yeah, I'd make it a little bigger than that. There we go. It's coming from Wisconsin. That's something I look for. United States. Okay. So what else we got this? Okay, does not include a power cable. Like I said, it's just a computer power cord. They're a dime a dozen. Don't pay $8 for one. I have a ton of them anyways. I don't even use them. No other details on it. So it sounds like this person doesn't know what they have. That's what it sounds like to me. Let's look at a bigger picture of it. They had something mounted on top of it. You can see that. That's why they got these pads. But anyways, it got rack ears. That's a $10 savings right there. It's got, this is, well, we got a bigger picture of that in a second, but I'm going to guess that's for a voice. It's probably your voice card. T1, it's your T1 connection. It has a cover. I like covers. This person does not know how to take a picture. Yeah, I can tell that see, that's blue. I can see it anyways. It's blue, so that's definitely a T1. Oh, it says it right there, T1 version 2. So anyways, these are about $10 a piece anyways. If you're going to study voice, you want them. If not, who really cares? Let's see. Yep. It says 1840, but it's an 1841. 1840 is just the series. Ah, it has a faceplate on it. That's nice. And that's nice. Alright, so those are all the pictures. I think, yeah, there you can see where it says 1841. So anyways, 20 to 30 bucks, that's about what I'd pay. I'd take a chance with this person, but that's my own personal opinion. Another option is 2811s. This has no rear, no faceplate on it. There's a cover that goes over this. It's missing. Whatever. As long as it works. But you'll have to do your due diligence. Do not buy these routers. The 1700 series. Do not buy them. Stay away from them. They are a big scam. They will not help you. These routers are nice, but they're loud. I used to have a few. I got rid of them. They do have gigabit Ethernet ports, so that's nice. But yeah, see, this is the faceplate I was talking about on that other one that was missing. Obviously, this one is larger, but same concept. This is what it would look like. And oh, here's a good. This is how I knew. See how it says that T1 DSU CSU, and then it says over there the WIC T1 V2. Yeah. Anyways, oh, it looks like it has 4. Yeah. But over there, see those yellow ports right there? Those are your gigabit ports. There's 2 of them on this. That is something that's nice about this, but I wouldn't buy it. 1841s with those specs is good enough. Okay, so enough of this crap. Our router should be ready. Let's not enter configuration mode. We'll do the same over here. You can see here, that's my 64 gigabit flash card that I have in here. That's good enough. And I'll show you right here, I have 15.1 M10. That's the version I like, 15.1, 4 in parentheses, then M10, mainline. That's what you have to know what MT train line is. T, M is mainline. You got to know those ones. Anyways, 1 second while I take a drink. Alright, got my drink. Alright, we're on router 1. Let's do the same thing. I'm just going to do this kind of quick. Well, let me show you this first. There's another trick. You're gonna have to know this one too for the exam. But normally I just can't type show IP interface brief. It doesn't know what to do with it. But if I do this, if I type do, now it knows what to do with it. Oh, there was something else I was going to show you too. Since these are real routers, I don't have the limitation of virtualization issues. Let's just type a command. Yeah, see, it doesn't know that, but if I do show I did want to do it bad. I wanted to do show. Oh geez, I don't know. Anyways, we're gonna just do this really quick. You can see it's just F00, and I'm just gonna give it the same IP address, and then no shut it. and go over to router 2. Well, here, let's do this first. So this is what I was talking about before. See how it says up, down? Yeah, it must be some virtualization thing. So anyways, protocol is down. That's obvious. They can't communicate. This other side's not even configured. So let's fix that. Whoops. Alright, now we're going to do and that's what I'd expect to see. I'd expect to see one failed ping, or 3, or maybe sometimes all 5 fail the first time. It depends on the latency of your network, how many hops it has to go through. You know, there's a lot of variables going on here. But anyways, yeah, that's that. So now we can do, whoops, let's just make my life easy. Show IP route. Yeah, it doesn't like that. Because of that stupid thing that popped up. So I'm going to fix that right now. Hostname, router 1, and then I can jump from one to another just by typing it. It knows where to go. There. Show IP route. And there we go, the routing table. I can show IP ARP. There's my ARP table. Same thing as before. Show IP route to this neighbor, and it knows. Now let's do show CDP. You can spell show CDP neighbor, neighbors. Show CDP neighbors. I don't believe the Cisco exam is going to ask you, is it neighbor or neighbors? I don't remember. But anyways, you can see there's no other options. So I just usually just do this. It sees router, because I didn't name router 2 yet, on this interface. As soon as I name it, that will appear. So let's do router 2, and then my favorite command, logging synchronous. And now we're going to see 2 neighbors, but watch the hold time. See how the hold time is slowly counting down on router? And router 2, it's counting down also, but let's just watch this. You'll see what happens. It's going to time out. Router is going to time out, and router 2 is just going to refresh itself. It'll count back up. It's losing fast. It's going. Gonna disappear. Yeah, see it? See how it went from 128 to 178? It refreshed itself, but this one, router, kept going, kept decrementing. So it knows that neighbor no longer exists. Just 30 more seconds, and we'll watch it disappear. Almost there. Three seconds to go. 2, 0, 0. Gone. See how it's gone now? It's no longer known. Okay. So let's talk about this for just a quick second. Device ID, that's the host name. This is the interface that router 1 sees router 2 on. This is router 1's interface. This is the local interface. Hold time, I think you just saw what all that means. Let's skip this for a second. Port ID, this is the remote interface. So this is router 2's interface that they see each other on. Okay, let's go back a little bit. Capability. We can look at our legend up here. R, router. And then a router is also a switch. And yes, you have to know this for the Cisco. And then IGMP. I don't know why they have that there. Ignore it. IGMP is not. Don't worry about that. It's not important. I don't think it's important in any Cisco studies anymore. But whatever. So it's capable of routing and switching. Because a layer 3 is also a layer 2 device, is also a layer 1 device. That's just the way it is. A layer 2, which is just a switch, is that a layer 3? No, it is not. There are multi-chassis switches, but in the CCNA world, that doesn't matter. You're not going to be tested on multi-chassis switches. So that's way beyond the scope. Or layer 3 switches. You won't be tested on layer 3 switches. Layer 3 switches can be 3750s, 3750Xs, 3850 or 3550s, the whole 3500 series. There might be some other ones I can't think of, but you don't have to know those for CCNA, just CCNP, but that's not important. And that's the model. It's an 1841. So we already know that. This guy, same table. We've already been over all this before. I'm not even going to go, I'm not going to show the hardware addresses and stuff, all that. You've seen all that before. We can do show CDP neighbors here. And you can see the same thing. There's an additional thing you can do with CDP neighbors, and it's called detail. A lot more information is right here. You can read through this and you can see a little bit more. What do you have to know about this output? Nothing, I would say. Maybe that's how you tell if it's doing CDP version 2. You don't have to know what that means. Just have to know that it's using CDP version 2. It used to be version 1, then things improved, and now it's version 2. You don't have to know what that means. And, well, that's just duplex. You will study duplex at some point, and there you can see it's using full duplex. But, just for funsies, what other commands can we type? A lot of commands. None that you got to worry about. So we're not going to worry about them. Now let's configure. I'm going to do router 3. She could have done this in the background, I guess. Whoops. Erase, yes. And Reload. We're gonna reboot it. Okay, good. Now we're gonna do another interface. Fast Ethernet 0, 1. These two are connected too. Let's give this an IP address of, oops, not 1, 2. We'll do 2.2. Just making things simple here. .2 because we're on router 2. Again, a class C address. We're just keeping everything simple, just the basics. And then we're going to activate it, and it'll do its thing. We don't really care. I guess while this is booting up, we've seen all this kind of crap before. Let's go to the internet once again, because why not? So there's a buy it now for 30 plus 15 shipping. It's not bad. I mean, shipping's not really that cheap, so I'd expect that being reasonable. This one looks like it's been a little bit in a dusty environment, but whatever. You can always open them up and clean them. Cisco's website has really good documentation how to open these up and whatnot. If you open up a computer case, though, it's really not much more complicated. I cannot test, so if they can't test it, next. What's this guy say? This one looks like it's clean. I like it. And there's a 32 megabyte flat. Oh, megabyte, not gigabyte. It's 30. It's old routers. Oh, very, very old routers. It's using a 64 megabit flash. That's all it needs. This one doesn't say whether it actually works or not. I don't know. These 2611s, I mean, they're nice. You don't need them. You don't need the 2600 series routers. The 1841s are plenty. And they're quiet, too. The 2600s are a little bit loud. You got 2011 here. 2011s, I have a couple of these. I think I have 3 of them. I used to have a whole bunch of them, but I got rid of them because I don't need them. The 2000 series for CCNA, you don't need them. Way overkill. This one's nice though. It includes the rack ears. It includes the console cable, which is this nice blue thing. And it includes a power cable. With everything you need to get started right here. Free shipping. So if you got a quiet place to put it, or a quiet place, a place that you don't have to hear it. Let's see here. That looks like that's ready. Looks like that's ready. All right. Let's configure this interface. I mean, I even bought 3 1841s in a lot for like $90 plus like 20 or 30 bucks shipping. So my first one I bought was like $200 though. But that was the going price back then. So first thing I'm going to do is let's do something real quick. Let's just ping Google. See, it doesn't recognize it. Yeah. Anyways, host name, router 3, line con 0, Now I can go to, and I can do 2.3. Enable the interface. I think I enabled this one too, didn't I? Yep, I did. Okay, so now I should be able to ping them. Okay, it pings. It can also ping router 1. Okay, and router 3. Just gonna make my life easy. Come on. 2.2. So router 2 can ping router 3, and I can also do show CDP neighbors, and we see it's directly connected. CDP neighbors will only show what's directly connected, only show directly connected Cisco devices, because CDP is Cisco proprietary, Cisco Discovery Protocol. It just operates at layer 2. It doesn't need an IP address to function. All I really had to do was just activate the ports. I'm not going to show that. But anyways, we went over all that stuff before. Can this ping router 1? Any guesses? No, it can't. Because it's on separate networks. Okay. That's fine. What if I do this then? Is there a workaround? Whoops. That's not what I wanted to type. Let's go to router 2 and let's change it to in the same network. You know what? Let's do the same. Let's do this first. I'm in the interface between router 2 and router 3 right now. I'm going to try to put it on the same subnet and see if I can get router 1, 2, and 3 to talk to each other. I'm going to try to give it the same IP address on both interfaces. So I have this IP address is also configured on the interface that's connected to router 1. Let's see what happens. It says no, it overlaps with another interface. Okay. So what if I do a different, let's do a different one. Let's get 12. No, it overlaps it. Why? Because it's in the same network. You cannot have the same IP address or the same IP address in the same network on different interfaces for the same router. And I just showed a demonstration of that. So how can I get around this? Well, now we're going to start introducing routing. Before it's just, we're just going to go from one route, or just go from one router to the next. What if I want to go from router 1 to router 3? How can we get those to talk to each other? Let's do that. But first, I'm going to show you the routing table. And we went over this before, but now you see router 2 knows 2 networks. It knows the network connected to router 1 and the network connected to router 3. That's all fine. Actually, we'd expect that. So let's do this. Let's say router 3. We're going to do a command here. We're going to call IP route, and I want to get to that destination. And what is it? It is that. And how am I going to get there? I'm going to get there via this IP address. 3. Oops, did I do something wrong? No, that's supposed to be 3. This isn't backwards, is it? It's probably backwards. It's called the inverse mask. Oh, I know my mistake. Okay. This is the right command right here. That's the right mask. But there, 0. It's the entire network. To get to the one network, that's how I go. Okay, whoops. The next hop, not the local interface. My mistake. My mistake. Okay, here we go. Now, did it work? Well, let's try it. Can I ping 1.1? We already know it's going to fail at least once or twice. Yeah, it's not going to work, is it? Well, we have to do something else. But let's try to ping router 2's interface. It's successful. Well, that's kind of weird, isn't it? Well, yes and no. It knows to reach that network, the 1.2 interface, excuse me, that IP address. Just go to router 2. Router 2 says, I know that. It's my IP here. So, because it's in the local routing table. But it can't translate that to router 1. So what do we have to do? Let's go to router 1. Let's point router 1 to router 3. Let's see what happens. IP route. Definitely not a J in that. 2.3. And I know that's going to do that one. Oh, I messed up again, didn't I? There. Okay. Let's see what happens now. We're just going to go to router 3. Now it knows it. All right. Well, can router 1 ping it? Yes, it can. There we go. We have routing. This is called static routing. If I was to add a 4th router, and I wanted all 4 routers to talk to each other, there's a formula. I'm not going to go into it. But I'd have to add a static route to each router to point to each other router. So you can see this doesn't scale very well, but for just very, very, very small networks, like 2 or 3 routers, it's not that bad. Let's look at the routing table. This one looks a little different. So I mentioned before it was a static route. Well, we know what this top means already. We went over that. But this is S. S means somewhere. It's up here. I mean, I already said it. But anyways, S means static. All right. And you can see there's other routing protocols. Like you got RIP and BGP, EIGRP, EIGRP external, OSPF, blah, 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 blah. Anyways, there's a static route. To get to that network, go to that next hop. Remember, that's router 2's IP address. So we're going to just send it to router 2. Router 2 knows what to do with it, because it's in router 2's local routing table. That's why it knows what to do with it. If it wasn't in router 2's routing table, it would know what to do with it, which is why router 1 and router 3 had no communication. Right. Now we have this. It's in this. But I'm not going to go over all the details. You don't have to know all this right here. You don't have to know what that means. There's a lot of stuff you don't have to know. You don't have to know is. You don't have to know on-demand routing. That's not even used anymore. That's really super old. Like a lot of this crap. Lisp, NHRP, which is still valid, but don't worry about it. It's definitely not CCNA level. For the CCNA level, you just have to know... Wait, I take that back. You have to know that. And... that's it. You have to know these 3 things. And we just covered those. Let's do one more thing. Let's go to this configuration, and to get rid of it, I just type no. It's gone. It's no longer there. Let's type it differently. IP route 192.168.2.0. Whoops. Yeah, we'll do this one first. To get to, what's it, router 3. So when I turn all the bits on, remember, that's a /32. We haven't done subnetting, and I'm not going to do it in this this video, but that's the same thing as a /32. It's a host. So that means it's a host. And then I just do that. Will it work? Of course it'll work. Of course it'll work. And I'll take it out again with the no command. And I'll try to ping, and it won't ping. Now let's just continue doing this, and doing this. I can do Control-Shift-6. And it kills it. Alternately, I can type a high number with the repeat command, and it'll just keep doing this, which is good if you're doing labs and you just want to see stuff without having to go back and forth typing ping a whole bunch of times. But I want to kill that, so it's Control-Shift, holding Control-Shift down. Let me say that a little more clear. Holding Control and Shift down, I'm going to tap the 6. And then release all 3 keys at once. That's just terminates that process. Okay, all right, enough of that. Let's let's type the static route again one other way. And I already showed you the first couple variations of this, but I'm going to stick with this one. This next one is, well, here, let me show you. With the question mark, you can see I have the option of fast Ethernet. So I can type that, fast Ethernet. And now I just give it a number, 01. This is the outgoing interfaces ID. Now will it work? Well, that command won't work, but this one will. Or maybe it won't. Okay, it won't work. I thought it would. Why won't that work? To get to there, send it off to there. Okay, I don't know why. Are there other options? We don't have to track it. Oh, I have to type this. That's right. That's why. Forwarding router's address. So my local address is this. Yeah, on that interface is this IP address configured. Did I do this? Oh, whoops. Forwarding router. That's the next hop. Okay, here we go. Now let's try it again. Okay, I don't know. I don't know. I'll have to play around with that and put out another video later. Alright, so what is, let's see, we looked at that routing table already. Let's look at router 2s. We went over the routing table before. It's the same thing. Because there are no static routes configured, they're not shown. Router 3. I should not be able to ping it because I don't have it configured on router 1. Yeah, it's not going to work. Even though it won't work, which I just showed, it's a static route. So it's in there. It's not going anywhere. So, yeah. And I already went over what all this stuff means. But, yeah. Let's end it getting the routing working here. I really want to get this to work. Do I have to type that? Oh. Cannot install enter topology. I didn't think so. Okay, I don't know why that's not working. So what does this all look like that we've done? Well, let's do this one first. No IP route star. There. Boom. All the IP routes, all the static routes are gone. Alright, what's all this look like? Alright, we'll start at the beginning. We're in user exec mode. Let's look at it. Show running config. That's the whole command. It doesn't like it. Why? Because you are in user exec mode. You're not in privilege exec mode. Alright, well let's go in there. And I can shorten it with show run, and you'll see it auto completes it. Alright, so I'm not going to go over this line by line. You can pretty much read this and see what it means. You don't have to worry about this stuff. I guess I can cover that later. I don't even know if you have to know that. That's our host name. You can skip that. You can skip that. You can skip that. Skip that. You can skip all of this stuff. Yep, you don't have to know any of that. There's our interface. We can see that's configured. Oh, that's my mistake. That's got to be my mistake. Hang on. Hold the horses. Dummy me, I'm thinking I'm on a different router. Interface. Okay. IP route 192.168.2.0. And let's do Path Ethernet 00. Okay. Now it's successful. Alright, let's look at the routing table. There's our static route. Bam. Okay, my mistake was I had the wrong interface. I was thinking it was going out interface 01, when in fact it was going out 00. So, anyways. Alright, let's go back to the show run. Now that we have our static route in there, we'll see where it's at. You can skip all this stuff. Okay, so here the interface is configured. This stuff is just a default duplex auto, speed auto. You may or may not see it in some versions of the operating system. But anyways, my serial interface. You don't have to know serial anything for the CCNA. However, serial provides some interesting configurations. And you kind of understand a little bit more of the service provider side, the WAN side, the wide area network. You kind of understand that stuff a little bit more when you start playing around with this stuff. But again, it's for CCNA, not important. You can skip all of this stuff. You don't have to know what any of that stuff means. This is the static route that was configured. I can do the permanent keyword at the end if I wanted to. I can also do that IP address if I wanted to. I don't have to, because there is only one IP address on that interface. If we had sub interfaces configured, you know, things, but whatever. You don't have to know what any of that means. There's our console configuration that we did, logging synchronous. VTY is how you can SSH into it, virtual terminal line. Yeah, don't have to know what any of that means, and end means, well, that's the end of it. The exclamation point just means it just skips it. It doesn't do it, so I can just type hello world, for example, and it's, you know, doesn't do anything. Doesn't try to execute, doesn't do anything. And there you can see it tried doing something, but, you know, let's try something real quick. IP domain lookup. And let's do now we have it looking for an IP domain. So here's what I'm talking about. Okay, so this version of iOS I have, I didn't know this. Maybe in 15.1 code and above, they disabled it. But yeah, they kind of streamlined it a little bit too. But you can see it tried to resolve that domain name. And obviously it's not connected to the internet. It's not going to work. I could connect this up to the internet and it would work, but I'm not going to. So anyways, no IP domain lookup, and it's gone. Now if you want to save this, well, we can't save it here. There's nothing to do. So does save work? No, save's not going to work. So copy. It's running configuration, or running config, and then start. So I'm copying what's currently running, because right now all the configuration changes I did are in running configuration. They are in RAM. RAM is volatile. Volatile means as soon as it loses power, it wipes out all the contents. Hence a reboot, a power loss, turning it off, it's gone. We need to save that. Well, I talked about flashcards earlier. This is where the router stores the RAM at. In different versions or different models of routers and stuff, they may have a built-in capability to do this. But for the 1841s, it's a CF card. So anyways, it's copy, running configuration, startup configuration. Now the startup configuration is going to save this to NVRAM, non-volatile RAM. RAM being random access memory. So NVRAM is permanent. NVRAM is on the CF card. That's what the CF card is called. So here we go. What do I want to save it as? Well, we'll just use the default. For the CCNA, just use the default. Don't worry about changing it. Don't worry about any of the other stuff. All right. So now we can do, before I did show run, let's look at show start. Let's just start up config. It's the same thing. It's just, you see I've got the host name configured, and there's my internet, or my Ethernet. Let's go to this router. What is show start? Not present. I didn't save one. Okay. It's kind of weird. This is a Linux operating system. I mean, it's very stripped down and customized. But you type a Windows command to look at the directory. Yeah, I don't understand that either. I have some stuff on here that I've been working on. So I save the configurations with different names. So if I want to go to them, I can do that. I don't have to. But this is what I do when I want to work on labs. And I want to save those configurations to go back to the beginning of the lab without having to reconfigure the entire router. But again, that's beyond the scope of what we're going to talk about. This is the image name. So when the router boots, it looks in the flash, which is the compact flash card, for some bin image. This is a bin image. And it sees it. And this number is important too. So let's show you why that's important. All right. So if we look at, pardon me while I scroll through this, it usually takes me a minute to find it. Looking for, here it is. I have 62K is 1,000. I have 62,000 bytes of flash memory. Okay. And I have 191,000 or 192 megabytes, because there's no such thing as 191 megabytes of RAM of RAM. So, anyways, this is what we're interested in. We're going to go back to this, and we see 1,000 there. Now this is in bits now. We see 100,000 there. Technically it's not 100,000, I'm just... And we see 47, or 100, yeah, we see 47 million there. So what do we do to convert this? Just quick down and dirty. Get rid of the last three, and now we'll look at these ones. We have 47,000K. So, yeah. That's how much available space we have on that flash. And our image, or excuse me, not on our wrong word. That's how large this bin file is 47,000K. So now we'll go back to our flash, and our flash is 62,000K. We have plenty of space on the flash card, in other words. You don't have to worry about that. The next size lower for flash is 32K. Will a 32K image, or will this image fit on a 32K flash? No, because it's 47K. It's much larger. That's why I recommend the 64 megabyte image, because this is a 47 megabyte image. Okay. Do I want to do anything else here? Yeah, let's do this. Let's go to router 3. Whoops. Show IP route. Well, let's just look at the routing table. We've seen this before. All right. Nice. Let's go to 2.3. What's that look like? Ah. So it knows it via connected because it's somehow connected. It knows it's connected to... Oh. Wrong IP address. Not what I wanted to type. 1.1. Okay, here we go. Here's what I wanted to look at. Okay, show IP route. It knows it via static. That makes much more sense to me. It knows it's 1 hop away. Notice this, it's 0 hops away. Because it's directly connected to router 2, it knows this IP address is 0 hops. It doesn't have to go anywhere. It just goes to the next hop. That's it. But it knows it has to go past one router. So it's distance of 1 hop away. Okay. So it knows to reach this network, it has to use it has to go through this network to do it. In this network, you can do show IP route, or you can spell it how you want to spell it. I think Cisco recommends that way though. And how do we get to that? Sorry, that's my mouse wheel again. So before we knew we had to go there, that was the hop we had to go to. So let's look at that. It's directly connected via fast Ethernet 0/1. So we have now traced it. So to get from router 1 to router 2 to router, or excuse me, let me backtrack here. To get from router 3 to router 2 to router 1, we trace the entire path. Now we know. Is there anything else I can show about routing really quick? Well, no, I think that's good enough. So I hope this quick down and dirty, you're able to see what's really happening, how routers communicate. You saw some of the problems between a virtual environment and real routers. And if you're in your lab and you're on virtual equipment and you notice some weird things happening that the instructor on the video you're watching or the book you're reading doesn't quite match, because in the book they most likely are using real equipment. So things are sometimes a little clunky or a little wonky, or just kind of like, why is this behavior happening? Well, you saw examples of that. We went through static routes. We went through directly connected routes. What else? I talked about a little bit of the different routers I recommend buying on eBay. As far as Ethernet cables, since I talked about that, I talked about buying routers, let's talk about Ethernet cables. All right. So let's go to monoprice.com. Wow, they changed their website. Let's just look for Cat 5 cables. Okay, here's a 5-foot cable for 96 cents a piece. And you can get up to 100 foot for $13. You can't buy that locally for that price. That's a really good deal. Not sure I like the metal around that, because that does sometimes cause a little bit of issue. But for a router to router connection, if you've done your studies, you know a straight through will not work. So let's see here. Where's my crossover cables? Yeah, I don't know off the top of my head. Let's look at. Okay, is there a different configuration here? Well, you'll have to find them. I am not going to. Well, let's try one more thing. There we go. All right. I like to have my cables different colors. So I do have red crossover cables, but I like orange as my crossover cable configuration. And then gray is usually my straight through cable, or black. I have black. I buy my cables in bulk of 1,000 feet, and I have all the colors I need, the 3 different colors, and I make my own cables. But if you're just gonna set up a few routers, maybe 4 or 5, and you're just gonna connect them, and you got a couple of switches, then which I haven't even covered switches. I can go over to those details later. Just buy these from Monoprice. A little more expensive, but that's because I don't really know why they're more expensive. Doesn't make any sense, but whatever. This one's 7 foot. That's why. Well, even 3 foot's more expensive. Yeah, I don't know. So make sure you have cables that are long enough. As far as the length goes, I mean, it's a lot, but I mean, 50 foot, you're not going to see any difference between 50 foot and 3 foot, other than 3 foot is going to cut you short if you're not expecting it. So 7 foot is usually a really good number. That's why it probably defaulted that. That's like the default size anyways. If you were going to make your own, you would have to have crimpers. You'd have to buy the ends. You'd have to buy a tester to make sure it's fine. You have to have some kind of tester. Otherwise, you're going to, like, why is this not working when you plug the cable in? I mean, there's all kinds of stuff. And that's a good skill to know, but you don't have to worry about all those details. This is just a cheap tester for $24. My tester, I would not. Even this one, I wouldn't even use this one. That's just me. Here's the serial cable I was telling you about. Yeah, these are more expensive, but then you get to have fun with them. You have to have this particular serial cable to work. It's a crossover, going from device to device, right? I was hoping to show you. Oh yeah, here's a good picture. Can we show? Oh, that's a nice. See how that's trapezoidal? Yeah. So Monoprice makes some good cable, or good. They make good cables too, but they make good connectors. So, yeah, but there's no marks that are industry standard to tell which is the top, which is the bottom, which one orientates which way. You just have to do due diligence to see that. But yeah, that's all that cable is. And you can get it in different lengths. I mean, for me, I think I just have 3-foot ones. I think. And I have like a dozen of them. And I've only had one go bad. So, yeah. But anyways, when I talk about switches, then we'll go into eBay and I will talk about switches. Trying to think if there's anything else. No, I think. Oh, yeah, Let's go back to eBay. And let's talk about. Let's do a Cisco console cable. These things are a dime a dozen, and most of the time when you buy a router, they're included. I mean, I don't think I have that many of these left, but I do have some. Anyways, this is just your standard cable. It's a console cable, 9-pin serial to a crossover. And when you do your Cisco studies and you're reading the book, you have to know these pinouts for this right here. You do not have to know the pinouts for the serial side, but you have to know the pinouts for the RJ45 side. It's not a big deal. I'm not going to go over it, but it's pretty easy. Yeah, $1. I'd buy that for $1. Nothing wrong with that. Even $4. I mean, it's worth $4, but also, because this probably won't plug into your computer, you're going to have a USB to serial adapter. Now this is where you're going to get into the tomato, potato argument. Is Ford better than Chevy? Is Toyota better than Chevy? Is Chevy, better than Nissan? That's the kind of argument you're going to get into. I like these cables because they have a cable on them. It just plugs into USB on one side and the console cable plugs into the other side. You will need something like this. It's a little high for this type of cable because that's not exactly a high quality cable. This one, I don't know what the hell that is. Okay, if it's 6 foot long, that's worth it. And these, I have found from my experience, are just plug and play. That's a little bulky. This is probably the exact one I have, I think. It was just included. I didn't actually buy it. Like I said, it's included in the equipment I bought. So, yeah. There's also these type right here. You'll hear people say different things about them. I find they're plug and play and they work right out of the box. No problems. So, yeah. As far as it working on a Mac, yeah, good luck getting the console stuff to work on a Mac computer. There's some funky things, and I am not even going to go over those. Because the console will work, but when you try to do other stuff, like go into RON configuration mode, there's no break key on a Mac keyboard. So, yeah, good luck figuring that one out. There's ways to map keys and funky stuff like that, but, you know, I don't do that. Sabrent, this is a brand name. I mean, you can go to Newegg and buy this. Oh, this is the one I have right here. No, it's not. I take that back. Looks like this one gives you a couple of options. Oh, no, it doesn't. No, that's a different USB connector. So, yeah. So there's some different, a whole bunch of options. I mean, these ones are nice, but they put stress on your computer USB port. So I wouldn't use them unless you had to. That's why I like these ones right here. I guess I'd pay $13 for that. But there's also Belkin, right? So Belkin makes, this is a new one for $16, brand new. $20. You might pay up to $30 for one. Look for a brand name one. Belkin's a good one. TrendNet is another good one. What's it? TrendNet or something like that. Yeah, this is a good one. Yeah, I don't care. This is, yeah. So you can go to these manufacturers' websites and you can look up the USB drivers because you'll probably need it for like the TrendNet and the Belkin. So you'll be able to get the drivers. Trying to think, is there anything else? I guess if you're going to buy routers, you're eventually going to want to do this. A network rack. Now, there's some expensive ones here. Blah, blah, blah. You don't need any of that crap. Although they're nice. But if you just have like 5 or 6. Hey. There's one for $1. 4 days left. If I want to go to Florida and buy it. Okay. Alright. That's enough, Tim. Let's keep moving. All this stuff. I'm looking for... Okay. Okay, here we go. So here's a 6U one. I talked about U a little briefly. U is the height of the device. There's 1U, 2U. I mean, there's like U's that take up an entire rack. Anyways, I guess, I mean, that's an enclosure right there. The only problem with that is, well, it'll fit the 1841s just fine. But when you start buying bigger devices, yeah, you gotta worry about the depth. There's this one. I would not pay $65 for this. I wouldn't pay over $20. Plus shipping. Shipping shouldn't cost you that much. So yeah. There's another one. So these are the different racks you can buy. There's a ton of them. There's something I heard where, let me look this up here real quick. I heard you can do some plastic shells. So maybe something like... So maybe something like this I heard you can do. I heard that this is... perfect size or some, well, heard. I've seen pictures. I've seen pictures where somebody took one of these shelves and I don't think it was this shelf though. This one's $40. You can get them cheaper. But yeah, this area right here is 19 inches wide, which is perfect. So anyways, you have some different options. Alright, well, that's going to be the end of this. So thanks for listening and watching, and I hope you have fun in your lab. This quick and down and dirty example. This is where the book is taking you. This is where the exam is going to lead you on, and there's a lot more depth to it. All right, have a good day.